Welcome back everyone to Data Science for Everyone. Today we're going to be talking about clustering with PySpark. Let's get started. So today we're going to be looking at, again, clustering with PySpark. We're going to be using two different data sets. We're going to go through their sample k-means data set, which is a little tiny data set, and then we're going to be going over the UCI data set for the seeds data. These are pretty common clustering algorithm practice sets. So let's go on and start out with the basics of k-means. So k-means is probably one of the most common algorithms that we can use for clustering. And it's going to be using data points of some predetermined number of clusters, hence the k in the k-means. So let's first get our PySpark session started. So from PySpark .SQL, we're going to import our Spark session. And then I'm going to go on and create the Spark session here. Spark session, we're going to use the builder again. We're going to create an app name. And I'm going to call this sample cluster get or create. And again, the reason I'm doing that is because I'm using this sample k-means for our sample here so that I can differentiate them later on. Now we also need to go through and grab the model itself. So from pyspark.ml.clustering, we want to import k-means. And just to make sure here, this is a capital M in there. Let's load up the data. I'm just going to call it df. Spark.read.format. And then this is again in that libsvm as Spark libraries kind of like to play on for their samples. And this is called sample k-means data.txt. And again, this will be in that column, the features and the label format, so we can take a look here at that. And so here we have the label, and then we have the features in here. And you can see here some of them may be missing some features, or there may be some other information in there. This is just a sample data set, so it doesn't have to make a terrible lot of sense. It's just so that we can kind of set our appetite for trying out k-means. I'm going to call this k-means. We want a k-means here, and we want to do this as set k. And so here we're going to set it to 2 for the number of clusters, and we also need to set a seed, and I'm going to set this to 42. Then we also want to set our model, and then that's going to be k-means here dot fit, and then we want our data frame. So when we evaluate clustering metrics, okay, we're doing the within set sum of squared errors. So a WSSE, well, SSE, there's 3 S's in there, with the set sum of squares. And so we do model.compute, and here we're actually, compute is lowercase, and we actually are doing this with the cost. It's a cost computation here. And so on our df, and what did I mess up on here? Did they change the way that this is supposed to be done? Let me see here really quickly. All right, so let's go through and let's actually remove all of this, and let's actually fix what error we have in here. So I'm going to set this back to 42, and then we're going to fit the model to our data set. And this actually will follows a little bit closer to what we've done in previous models with like the linear regression, logistic regression. I guess they've changed up the format so that it actually fits those models similarly. So now we can make our predictions. So we do model.transform, and then with our data frame. And then we have our evaluator here, and this is a cluster evaluator. And so actually, let me put that in, let me put it right here with this. And so from PySpark.ml.evaluation, import clustering evaluator. I'll rerun that just for the sake of everything. And then we instantiate our clustering evaluator. And this will help with creating, like they call it a silhouette score. And so from the silhouette score, we actually create our silhouette. So eval.evaluate here on our predictions. And then we want something like, let's do print. Let's use an F string in here and do silhouette with squared Euclidean distance. So we'll actually set that up this way, and then we want this to be right here, and then we want it to be our silhouette. And let's take a look and see what that does here. So our silhouette score here, it looks like our predictions are about 99% accurate. That's not too bad. So then let's actually take a look at our clustering results themselves. And do something like, we need to calculate up our centers in here. And the center is, so if, let me grab a pen in here. And so let's say that you have some plane, okay, in here where we have data and we have a bunch of points. And again, assume that those are dots. Okay, and then based on our feature matrices, again, I'm doing this in a 2D representation. Technically, this can be like up to like a 10 degree or even more representation. Think about it in a 3-dimensional space. But what this is doing is grabbing, I want this, is finding the center point of those clusters for us to allow us to see those clusters. So in this example, I made 4 clusters for the 4 quadrants, but there happened to be 4. And so maybe, for example, if we did a K of 2, okay, so let me undo these. If we did a K of 2 in this instance, maybe it would say something like, actually there's one here, and maybe there's one down here where this whole section is a group here, and this whole section is a group up here. Or maybe it did it vice versa, and it was something like maybe these were closer, and so that was a group, and this was a group. So let's actually take a look at the centers then. So our centers is, whoops, click in here, is equal to our what do I want to actually run in here? So our model dot cluster centers, and then we'll do something like print cluster centers, and I want to do something print, and I want to put a nice line in here, and then for center and centers, print the center. And so this will tell us about where our clustering centers are for each of our 2 groups. So again, here they're all at going to be something like at 0.1 and 9.1. And again, we could later on we can even go through and plot these out to see what they look like. Again, this is just some fictitious data. Let's maybe go on to a little bit more concrete example. So let's say, let me see, what type of data can we use? Oh, we're going to use the seeds data set. And so let's go on to the seeds data set, and I'll have to do some of this on the fly from my notes to make sure that it matches up with our new example. But this is the seeds clustering data set from UCI. Now, let me actually even grab some information about this data set so that we can see this. So this clustering, I don't actually want this. I don't want any of this here. Or this here. I just want the attribute information. So this data set itself, okay, is going to be from 3 different varieties of wheat. Okay, now there's going to be 70 elements in each of them, and again they're randomly selected from this experiment, and again there's going to be high data visualization for the kernel structure, so how each seed is actually created, and that's the data that we actually wind up having here. They even have some of this data is even from, for example, from X-rays. But when they've converted them, okay, then this is the data that we get. So for example, we get the area of the seed, the perimeter of the seed, the compactness of the seed, and again, this is how it would be created, how it's calculated in there. Length of the kernel, width of the kernel, whether it's asymmetric, okay, so whether it actually has a similar shape on each side, and then length of kernel groove. Now, one thing that we need to make sure of is all of these also are continuous. Okay, so they're real numbers are not categorical in nature. So let's go on and start off with and continue on with this example. So again, I'm going to go through just like I haven't created a session yet. All right, and then Spark, we're going to override the sequence. We want a Spark session, builder, app name, and I'm going to call this seed or seeds, get or create. Then we also want to load in our model, and we're going to use again this this clustering. K means clustering. And again, I've already downloaded this, but I'm just running it again just so that we have a clear structure as to how we need to run our models. And so let's have our data frame is equal to spark.read.csv, and this is seeds dataset.csv. I believe that's what it was. It has a header is equal to true, and we want to infer schema as well. And that's not where my data is. Well, let me double check what it looks like here. Okay, I actually saved it as a text file. So it's txt. And let's see how that looks, if it will actually do this for me without having to do anything else. Show, nope. Okay, and so I need a separator in here. It's going to be a space. I hope so. Maybe it's tab. Maybe it's a tab separated value, so we need to kind of go through and just double check on each of these. All right, so it was a tab separated value. And where'd my header go? Hold on real quick. I need to, let's go back through real quick and check and see. Maybe the data that I pulled up is not the one that I want. Let me see here. All right, so this one doesn't have a header. Let's go over to the website really quickly. I have it right here. I want to look at their machine learning data sets. Let's go over, and I know that there's one. I want to actually grab it from a CSV file so you guys have a good practice example. Data sets. Oh, and you know what? Let's do, I want, which one? Their archive data, ML, and I want data sets. Oh, and this is also a good thing, I guess, for you guys if you want to see where you can find some good data. I'll actually just go to the data sets webpage here. And you can see here there are tons of data sets. So there's breast cancer data sets, badges, census income, there's even choral choir, all types of data that we can find, but we want seeds. And I want the data folder. And so they changed it so it doesn't have it does not have the names of the data. Did they? Where would I do that? I think I have a raw data set here, and let me pull it up because I want you guys to see it from a CSV file real quick. Okay, give me just a second to pull it up. All right, so grab the CSV version of this so that we can actually have everything in a nice clean format. This is something that I added in previously, but I just wanted to show you guys a nice CSV file because, again, most of you guys are going to be using CSV files with your normal analyses. So let's grab the descriptive statistics while we're at it. So df.describe .show, and I misspelled describe. All right, so again, everything in here, since it's continuous, we have full data. Okay, means everything looks okay. Again, everything looks pretty decent here. So let's go on and format our data to the way we want it. So because again, this is not how we actually want to see our data sets. We want to make sure that they actually look in that features and labels type format that we like. So from there, we need, from linear algebra, we will need to import vectors, and then from PySpark.ml.features, we want to import a vector assembler. Right there. Why? Import. Oh, whoops. That's because this is feature, not features. And then let's do df.columns so that we know what we're going to be looking at here. And we need to create our vector assembler. Assembler is going to be our vector assembler. And we want our input columns to be, we want all of them actually. So let's just df.columns. And then our output column is going to be features. And then we need to make sure our df final is going to be our assembler, and we need to transform our data. So now if we take a look at our data set, it should be in a correct format. Besides, again, we have our features column right here. This is what we're wanting. So the next thing we actually need to do, one of the issues is, notice that when we look at our descriptive statistics here, everything is in a different ratio or a different format. We need to make sure that these are scaled. Okay, we need to make sure that we have dimensionality reduction taken care of, and everything needs to be in the same scale. So again, here, for example, the mean is 14. Here, the mean is 0.08. Here, it's going to be 5. Again, we need to make sure that they're all going to have very similar distributions for their maxes and mins, etc. So let's make sure and do some scaling of the data. And so from PySpark.ml.feature, we want to import the standard scaler. So let's set up our scaler. We do standard scaler. We want the input column to be here, and we have features. And then our output column here, we're going to call it scaled features. And then we want to make sure that we do this with the standard deviation is to true, and we also want it with the mean as well. And we're going to set, actually, you know what, let's not do that. Let's set that to false. Whoops. Up. With. Set to width. Okay. And then let's make sure that we have our scaled model. And so we'll do scalar dot fit on our df final. And then we need to make sure that we look at our normalized data. So I'm going to actually just overwrite that final data. Scaled model.transform here, so we can transform the data on our df final. And we can take a look here, df final dot show. And we should see now over here, we can compare these two. Now everything is scaled. Okay, you can see that the numbers here changed. So they're all going to be on the same scale, which is going to be, again, that's necessary for when we're doing these k-means clusterings. Otherwise, it's kind of trying to compare like bananas to zebras. So now let's actually train and evaluate our model. So from this, we wanted to set our k-means. And we want this to do k-means, and we want our feature columns. And here, we need it to be our scaled features, okay? We have to do it on this scaled features column here, not on the features. All right, and then we're going to set k is equal to 3. And then we'll have our model is k-means dot fit, and we want this on our final data. So now we need to make sure that we go through and use our evaluators. So let's go through, and if I remember correctly, it's from PySpark.ml.evaluation, import clustering evaluator. Run that, and then we need to also make predictions for our model. Let me actually go and do that up here. Predictions is going to be our model dot transform here on our final data. Okay, and then let's go through and grab our predictions. So we want our evaluator to equal our clustering evaluator. Then we need to create a silhouette, and that is going to be our evaluator evaluate, and we want that on our prediction. And then let's do, again, print here, and we'll use an f string. We want silhouette with squared Euclidean distance. And then we want to put in, inside here we want the silhouette. And let's take a look and see what we have. All right, so here we're getting a little bit more reasonable than what our first model was. Okay, here we see that we're at a 63%, so maybe we want to change the number of Ks. Maybe we need to see what types of other features we could use to increase its potential. And let's take a look at, maybe we'll run this and let's change this to 4 and see how that works. And see if that's better or worse. See, that is definitely worse. So 3 is definitely going to be the way to go. And then let's also double check and look at our centers. So print, and we want what? Our cluster centers in here. And so for center and centers, print center. No, because I did not run this. This is still the same centers from before. So let's actually calculate up the centers as well. So let's do center, centers is equal to model dot cluster centers. There we go. Okay, now we actually see each of the centers for each of the groups. And here you can see that we have these 3 groups here, 2, 3 for our Ks, and again we have each of their centers. And we can also grab, if we want to, actually no, I think that'll be it. So this one, our accuracy is somewhere around 63%. Not great, but not bad. And we'll leave this here for now. Thank you guys so much. If you guys enjoyed this, please like, comment, and subscribe, and I'll see you guys next time. Bye-bye.